let us get started with the introduction to the data stage, where we are going to talk about where exactly this data stage comes in, and after that we will get into the details of the data stage. Yeah? So that is going to be the plan this today's session. After that I will try to talk about architecture of data stage and why this particular data stage architecture is far better in comparison with other ETL architectures of what we have in the world. If you look at this warehouse architectures, where there are 4 layers. Yeah? So first and foremost thing is what the source system layer, from where we are going to get the data, and the second layer is going to be what ETL layer, where we are going to convert one form of data to another form of data, and third is going to be the data or meta layer, where we are going to use this particular layer to store metadata and data, and fourth layer is going to be what presentation layer, where we could use this presentation layer in order to represent the data in different visualization format. Yeah? So these are the 4 layers of what we have in data warehouse architecture. Yeah? So that's what you can see it. Now let us try to talk about what happens on each of these layers. So first and foremost thing is what operational source systems or data from OLTP, online transaction processing systems. Yeah? So which means, let us take one real-time example. Assuming that there is a telecom service provider industry where they are providing services for prepaid, postpaid and so on. Yeah? Now, at the end of the business day or at the end of the business week, if the customer would like to know the business trend, which means what? So how many number of newly added customers in prepaid, postpaid and so on. Yeah? That's a simple example. So in order to meet that kind of requirement, what do we need to do? We need to know how to read data from multiple sources. Yeah? So which means, let us say prepaid customers data belongs to state 1, state 2, state 3, state 4 and so on. So first and foremost thing is what we need to know, how to read data from n number of states. Yeah? And each state data would have been stored in different forms. For example, in one state, assuming that they are storing prepaid customers data in a flat file. In another state, assuming that they are storing the data in what relational table. Similarly, third state, where they are storing data in some other form. So how are we going to read data first? We need to know that, right? After that only we can try to build a logic for the requirement of what was discussed just now, right? So that is where operational source system would come into picture, which means each state they maintain the data like a file or table or application or mainframes or whatever. Yeah? So but being a ETL solution provider, we need to know how to read and start applying what business logic. Yeah? So first reader part is going to be what should happen to the OLTP systems, which means we need to have connectivity, or we need to establish the connectivity from, let us say, our environment to the OLTP systems. Like database means we need to provide the right credentials so that we can get connected to that particular OLTP system and start getting the data. Similarly, if you want to read the data from a file, we need to know the location and the file name so that we could get connected to that and get the data. Similarly, if we have the data in the form of what CRM application or ERP or MRP or SAP or PeopleSoft or CVL or whatever, in case if we have the data in such types of applications, we should be in a position to understand like how to read data from those applications. Yeah? So similarly, if we have the data mainframes, we need to get connected to mainframes and start reading the data. So that's what we need to do in order to read data from n number of sources. Once we do that, what do we do with that particular data? That is where ETL layer would come into picture, where we have three what we call phases in ETL. One is what we call extract, through which we could able to read the data from multiple OLTP systems. Yeah? And T, which is once you could able to read that, T is a transform or transformation which will be used in order to convert one form of data to another form of data. That is where transform would come into picture. Yeah, like for example, performing group by operations or aggregations or some other any mathematical operation that you want to do, yeah, where there is a need to convert one form of data to another form of data, like a cleansing, filtering, standardization, decoding, and so on. Yeah, there are many things where we are going to spend a lot of time as part of this training in order to understand like the different ways to transform data from one to another. Yeah, and once we do that, yeah, then transformed data need to be sent to a target which we call data layer, where this target could be what? Warehouse, ODS, which is obviously data source, or data mart. Yeah? Remember, there are different what types of storage media, like a warehouse, ODS, data mart. These are the three things. Yeah? Now, when we use what, we'll talk about that. Yeah? So which means this is going to be the hardcore part of this particular training, where we could see there are several tools which will be used to take care of what we call all the ETL operations. Yeah? So one such ETL tool, and most widely ETL tool, in order to process very large data, DataStage is one of the good ETL tool. Likewise, we have many other ETL tools like Abinitio, Informatica Power Center, and Pentaho, Talent. There are open source ETL tools. These are the most popular ETL tools in the universe. Yeah? Now, yeah, which means what? Each tool will have its own way of performing extraction, transformation, and loading. Yeah? Now, DataStage is one such tool. What are the benefits that we have with the DataStage? I'll talk about that with practical examples as we go on. Yeah? And now, so as a result of this particular DataStage or ETL tool is going to be either EDW, which means enterprise data warehouse, or it could be MART, or it could be ODS. So that's about data layer. So I think you guys already have got experience, right? So we all know what is a warehouse, and we also know like what is a data mart. So let me just talk about just definitions or at a very high level. So data mart is a subset of the data warehouse. So which means we can maintain the data for different regions or for different data, different departments, or some other functional specific things. We could maintain separate data mart. For example, assuming that there are two regions, so functionally we need to maintain separate storage medias, one for one region, second for another region. So that is where what this particular data mart concept is going to help us. Which means what? Functional specific things will be maintained in separate data mart. And we have one more type of staging or storage media, which we call ODS, operational data source. For example, let us say we talked about requirement, right? To meet that particular requirement, we'll have to build either a single job or multiple jobs. I repeat, in order to meet a final requirement, we will have to build a single job or multiple jobs. And how are we going to make output of one job which will become as input to another? To do that, there is an intermediate storage media which we call ODS, which is operational data source, which means let us say output of a first job will become as input to another job through what? ODS, which means output of one first job will be stored in a staging area which we call operational data source, which means whatever we are going to store in this staging area which we call ODS, so that should not be used as a base to generate a report, because that particular data is still under operation, right? Yes or no? So job 1 output will be taken as input to job 2 and so on. Yeah, that's why operational, as the name suggests, operational data source, which means the data that we got from the source is still under operational. That is why we should never ever take this ODS data as an input in order to generate what? Reports. That's where ODS would come into picture. Yeah? So warehouse is what is the final data which would contain what? History of n number of transactional data which will be used in order to what? Generate reports and start taking business decisions. Which means what? So warehouse will be used ultimately for what? To take business decisions. Yeah. So which means let us say, as we discuss n number of states data, right? We read it, apply logic and store it in what? Warehouse. So anybody can take this data as a base to generate a report, and the customers, they can take a look at those reports and start taking the business decisions. That is where data warehouse would come into picture. And then we have a repository. Remember, if we have n number of records, if you want to read those records, you have to have a way to read it. That's where metadata would come into picture, which means metadata means what? Data about data, data over data. You can define several ways. In simple terms, like for example, name, address, 2 columns. If you want to read that, first we need to define name column with a type, let's say varchar, address, let's say varchar2, and so on, and length, nullability, and other external properties. All this will be contributed to form what? A metadata. Yeah. Now we know what is a metadata. We need to store this somewhere, right? So that same metadata will be used to read data every day, right? That is where we have to have repository. So repository is a place where we can store the metadata that will be taken as a base to read data based on every day or monthly or weekly or daily transaction data. Yeah? And the storing of this data or metadata can take place in one of these databases or files or even application. Mainly or mostly we use staging layer. We use what tiny databases like Oracle, SQL, or DB2. And when you talk about repository, also we use small databases. And when you talk about warehouse, then we need to think of using what? Very large databases where we can store very large data. Not only storing very large data, we can also use this particular database to retrieve the data in short span of time. That is what is very much required if you want to take any business decisions. That is where one of the leading, what is the largest database is what? Teradata. We also have some more like Hex, Notizia, and so on. But Teradata is leading the market. So most widely used what? VLDB, very large database, which will be used to maintain the warehouse, is what? Teradata. Yeah? So once we have it, then anybody, which means customer will expect the data in visualization formats, right? Like a graphs, charts, like a pie chart, bar chart, yeah, a line chart, or some PDF format, Excel format, or whatever, right? If you want to represent the data in the customer expected format, we have another layer which we call presentation layer, where we have several reporting, mining, and OLAP tools, which will be used in order to represent data in the customer expected visualization formats, like a Cognos, BO, MicroStrategy, and so on. We have different reporting tools which will be used to take care of generation of reports in the customer expected format. Okay? So that's about what architecture. So read the data, apply logic, load the data, and then use any reporting tool to read the data from warehouse and generate a report, take a decision. That's the summary of what we do as part of what data warehouse architecture. Yeah? So that's about architecture part. Yeah? So once we know this, then our primary focus, as I said, is going to be what? ETL, where we read it, apply logic, and load it to the warehouse. That is the scope of what? ETL. So that's where DataStage would come in. And now, once we know that, then we can get into what? DataStage, where we are going to talk about what we are going to cover as part of this particular training program in the context of DataStage, like right from introduction and setting up the DataStage, like installing it on your system, and then we have different types of DataStage jobs, which will be discussed in detail with practical examples. Most widely used type of job in DataStage is what? This parallel jobs. Yeah? So which means, as we all know that we get very large volume of data, right? So in order to process very large volume of data in short span of time, we have to think of using parallel jobs so that we can make this large volume of data to be processed in short span of time if you go with the parallel jobs. What kind of parallelism techniques that we have and how exactly we could achieve it by using DataStage, I'll talk about that in detail from the next session onwards, with practical examples. So from here, the specific topics would get started, which means how to read sequential data and what is the platform architecture in terms of hardware and software, which means what are the different hardware environments where this DataStage is going to get supported, like single host system and multi-host system, or SMP, which is symmetric multiprocessor, or clustered grid based multi-host, or simple MPP, which is massively parallel processing systems. So we'll talk about them in detail. Likewise, we have several topics: how to combine the data, how to sort the data. We have many topics. All of them are not listed here. Only some of the high-level bullet points which you could see as part of this particular course content. Now, once we know that, then the next step is going to be what? We need to start getting into the understanding of DataStage architecture, where we could able to see what DataStage follows simple client-server architecture, where we could able to see different clients in the client layer. Like we have a designer, director, administrator, repository manager. And we also have one more client which we call admin console, which is going to be the web-based client, which is not listed as part of this particular architecture. And each client has got its own capabilities. So out of n number of graphical user interface clients, we are going to focus on designer, where we could use this in order to build DataStage jobs. So that is where we are going to spend a lot of time. And whatever we are going to build, we are going to send those requests to a server. Server is going to service it, and that particular server can be installed either under Windows Server or Unix Server, and within which you will have built-in parallelism techniques within this DataStage server, which we call parallel engine, through which we can execute DataStage jobs in parallel. So we have a repository, we have a data, how one can process the data and also metadata. I'll talk about them in detail from the next session onwards. So this is a simple introduction. Here we read the data, apply logic by using a designer, and once you apply it, get it executed, output of that will be stored in a target. Target could be anything. So that's all will happen. Apart from that, if you want to automate this particular job or jobs, then we have a command line client like a DH job we have, which can be used to create a shell script within that called DH job, and call that shell script from third-party scheduling tools, so that we can automate DataStage jobs by using command line utilities, which is what happens with what command line utilities, right? So that's about what command line client. But I'll get into the details, like what each client does and when to use what in detail from the next session onwards. So far, if you have any questions, please shoot out now so that we can discuss. So remember, I have, as I said, I have more than 17 years of experience. So you can ask questions at any time. You can interrupt me and start asking questions. So I'm supposed to answer any kind of question at any time. If you have any questions, please feel free to ask so that we can make it more interactive.